Hello, hi, I'm Ian. Thank you for coming to this session. Today we're going to be looking at cloud events and we're going to be looking at an event-oriented machine learning workflow. We're going to be checking out some interesting technology in BentoML and KFServing and Tekton. And we're going to be using them to kind of explore cloud events and do something interesting with them. In the process, hopefully, I will show what cloud events are, but more like what can you use them for, and also explore some pretty interesting technology. First off, hello, I'm Ian. Um, I work at the Open Source Technology Center at VMware, and I've worked on basically infrastructure as a service and platforms as a service and application deployment systems in some form or the other for the last 17-ish years. In the past, I've worked in a lot of different places, but some of the more recent ones have been Heroku, Engine Yard, Deis, and Packet. And I focus primarily on machine learning nowadays, which is pretty awesome. I thought for today we could use this objective to leverage an event-oriented machine learning workflow. And we can do that to do something useful with cloud events. Because I feel like that's pretty much an interesting way to learn about something, is to do something useful with them. And cloud events as a spec is just begging to be used. So to set some simple goals for our demonstration system, our experiment system, we want to be able to experiment locally and build and deploy in our staging cluster. This is just because this is the way I work. As when I'm doing any sort of data science or working with features or doing any sort of experimentation, I'm generally starting by experimenting locally. And then at some point I'm going to build and deploy, but that's going to happen in a cluster somewhere remotely. And one thing that our system should also provide, or is desirable, is the ability to share these trained models with teammates easily. So some way to version these models and share them and have them be able to be used by colleagues in a really straightforward way is desirable. And also, we need to build and deploy specific models. So not every model that gets deployed should be built into a Docker image and deployed to a canary, just the ones that we really want to intentionally proceed with. So some mechanism to handle that inherently, and that should be handled from the CLI, from the notebook, or we should be able to deploy via CI/CD in a headless mode. Lastly, our last simple goal is just a safe way to deploy the model API services. So some way to have something like a canary deployment where you're deploying the canary and it's getting some percent of traffic, and we also want to take it one step further and say that we want to auto promote that canary. If it's getting 10% traffic for 10 minutes, let's say, and it's below the threshold for whatever query we want, then it should auto promote. So we want to handle that as well. To do that, we're going to use these components. We talked about cloud events, and specifically, we're going to be making use of the Python SDK. BentoML is a really interesting piece of technology that allows us to have some glue here where we can save our machine learning models and retrieve them in our CI pipeline. We could also retrieve them, though, as a colleague. We could also use it as a way to keep versions of our models. So it's a pretty flexible piece of code. Tekton is going to be the heart of the build system, specifically Tekton pipelines, but it's going to be Tekton triggers that is doing a lot of the interesting work by receiving our events, our cloud events, parsing them, and creating pipeline runs based off those events. KFServing will also come into play. That is how we're actually going to boot our canary and promote it using the KFServing SDK. And of course, KFServing is built on Knative, so we get lots of good goodies for free there too, like scaling to 0. And Prometheus is how we're going to do our auto promotions. We're going to await specific criteria in Prometheus using Prometheus Gate. And that's going to allow us to say, you know what, until this has been error-free for 10 minutes, we're not going to run the promotion. To dig into cloud events very quickly, to give some background on what cloud events are, they're a vendor-neutral specification for defining the format of an event. It's just a way of having consensus about what an event format, what the event envelope should look like. And it's not going to work, of course, for everything, but for most things, having some sort of consensus can work. And that really eliminates a lot of headache in the early stages of a project, especially. But most importantly, and the thing that I like best about Cloud Events is that they provide an SDK for Python, Go, Rust, Ruby, Java, C#, PHP. So if you're working in across teams or inside one team or across languages, a lot of times it's very nice to have those SDKs around. The spec for Cloud Events is pretty simple. There's 4 required fields. The ID field is required, as is a source, where the source of the event is. Also, the spec version, in this case 1.0, and the type. The type is an important field because it kind of works like a namespace a lot of times, or a way of kind of really thinking about the hierarchy of your event structure as you name them. And the content type is an optional field, as is schema. The extensions are optional, as is subject. And the payload, of course, is where we're going to be including our payload, which in our case will be serialized JSON, a serialized JSON payload, which we will see here. On the right here, that is the JSON payload we are sending from our local notebook up to our build context. It just has a service name and a service version. Provided that, the rest of the magic can happen. And on the left, there are the fields we just discussed. The content type is JSON. I am set to the source, and the type is build.canary.release.encoffey. So BentoML we mentioned is going to be a big part of this workflow we're envisioning here. BentoML makes it easy to build API endpoints and to save ML models, and it supports most major frameworks, which really is great because it supports TensorFlow and Keras, Scikit, which we're using, Onyx, PyTorch, XGBoost, H2O, and FastAI. So again, a lot of overlap here, a lot of support for lots of different libraries means lots of interesting integration opportunities. And really, it can kind of also, in a way, store as a common interface to store and retrieve different model formats. So across teams, if someone is using Keras and another team is using Scikit and they're interacting, I mean, there isn't any reason that this same technique can be used. Models in BentoML terminology are packed. They're basically loaded into the service that you define. So if you define a new service that you want to run an API for, you load the model, the train model, so to speak, into that service, and that will allow you to save that service revision to a backend where it will be versioned and kept. These models then, once they're saved to that common backend, they can be served or retrieved anywhere via the CLI. And the retrieve part's really interesting because it gives you an entire build context with it. That's where Tekton comes in. The pipelines for Tekton provide resources for declaring CI/CD pipelines. The pipelines themselves are defined as sets of tasks to be executed in some defined order. And tasks themselves are just pod runs, and they have multiple container steps declared to accomplish the task. So you could have a task with 6 steps and a pipeline with 3 tasks. The input and output between steps is generally provided via a physical volume. Triggers is a project I had the privilege of creating with a few wonderful people last year. It's literally just, at this point, an HTTP event listener that accepts events and has some very powerful capability in that it allows you to extract information from those events and populate a templated Kubernetes resource as a result. And these resources are limited to just Tekton resources. So you could template out a pipeline run, for example, which is what we're doing. that opens some doors to some really cool integrations, this being one of them, I think. And task catalog is another thing that we're taking advantage of. A lot of the stuff we're doing here has already been contributed to the task catalog, and more will, but it's just a catalog of resources designed to be reused, which is a beautiful thing. When people stop having to rewrite the same thing over and over and over again, and we have a generic resource for it. And they're just, little composable pieces of code, highly useful, highly generic, and I find that very Unix-like. Prometheus I mentioned as a component in our system because we need a way of automatically saying, okay, the canary has done well for the last 10 minutes, let's promote it. Prometheus is just a systems and service monitoring system, extremely popular, as I'm sure most folks in this room have had some exposure to Prometheus. Fundamentally stores data as time series, and it collects or scrapes any configured targets, and there's a number of ways to achieve being scraped. For our purposes, really interesting that it exposes an HTTP API because that's what we're going to be using to make range queries from our Prometheus gate via the provided client libraries so that we could pause pipelines when we need to wait for conditions to be true, such as when we want to wait to promote our canary. And Kubeflow Serving, lastly, super interesting project. It builds a top Knative. And so we get that same scale to zero capability. But the inference services that KFServing builds even further and introduces the defaulting canary model right into the inference service. So that's what we're going to be deploying, is a canary with both a default and a canary in our inference service. And then the KFServing will expose a predictor. And that means that the deployed model server is going to be called, the traffic is going to be routed to it. If it's not scaled up, it's going to be scaled up. It's going to have its predict function called, which we defined in BentoML, remember, and it's going to return the prediction. So let's check out our demo environment. We're going to have some aggregated pod logs in one console, and we're going to watch the ML namespace in another, just because that's where we're going to populate our machine learning inference services. So let's pop over to our notebook here. So in our notebook here, what we're doing, this is setting the backend service for BentoML that I had mentioned. So we're going to set that to our cluster so that we can save our models to it. We're going to write our model. This service you can see here, this is how BentoML determines that we're going to be auto-resolving dependencies, and also that we're going to be serving a scikit-learn model. So now we can have our BentoML service defined. This little bit here is actually the scikit-learn demo dataset. We're going to be loading the iris flower dataset, and we're going to be using our recently defined iris classifier as well. So let's build and fit our model with the example dataset. We're going to be using the svm.svc model. And now let's pack that model into our BentoML service. And lastly, we'll save that model to our BentoML backend. While that's working, that'll take a minute because it's actually saving the model there. We can see that BentoML also provides a pretty interesting web interface. Shows us all sorts of interesting metadata about each service that we've created and stored. And over here in this tab, we can see that the service is still chugging along. It's pushing up the pickled model. Each ML format it supports will save to whatever it is natively supposed to save to, and BentoML just kind of handles the pickling and unpickling. We can see that it was saved. We get a new unique identifier here, and we can see that our artifacts are also saved to our S3 compatible backend. So let's see what that looks like on the CLI. Let's use this BentoML CLI to list our results. We can see we have a new release, or excuse me, a new service that's been defined as of 23 seconds ago. And if we if we define that and we want to retrieve that service that we just defined, this is interesting because it's not just going to retrieve just the model in the serialized format. As we can see, we've checked it out to temp-c. We get an entire build context from BentoML, generated for free, which is really useful. And that's what we're going to be using in our Tekton cluster. So let's create a cloud event. This is using the Python SDK. We can see that our payload here is service name and service version. These are just the versions that I was just talking about. This is all we're going to have to tell our cluster because the rest of it can be inferred. So we're just saying we want to build an image for our iris classifier model that we just created. And we want this version, the one we just built, to be built into an image. And we're also specifying our build.canary.release.enCoffee event. That's going to signify to our trigger how we're going to want to handle this. So let's go ahead and create that event. Lastly, let's again use the Cloudevents SDK to send our cloud event. This is our Tekton triggers event listener, which will parse that JSON serialized payload. And as fast as we can switch over, it's still not going to be fast enough because stuff's already going to be happening in our logs on our remote cluster. We can see here that the BentoML service in the Tekton step has already run and retrieved our iris classifier version that we just built. And now the Canico build step is going, and this build step is going to do a whole bunch of things. But while this takes a few minutes, let's go back and talk about what's going on here. We can see in this diagram, if you start at the dashed developer local place, if you were to go down, that's what's going on now. We started the pipeline event via cloud event. They deployed the canary deploy pipeline. And we go down this left side here. BentoML retrieved the model artifact on the remote cluster with the entire build context in tow, pre-populated into that directory. Finally, or next, the Canico task build, all it has to do is take from there because it already has a defined Docker build context directory. It just will say, hey, I'm going to go and run this and build the image and save it to our Docker repository. That's what's actually going to take the longest here. It's probably going to take like 3 or 4 minutes, so I'm going to talk slower. But once that image is built, as you can see, the next task here is for Kubeflow KFServing service to create a canary. And that canary is going to get 10% of the traffic, and 90% of the traffic is going to continue going to our previously stable image. Once that's been done, the final step is to send a cloud event. So our pipeline sends a cloud event at the end to the Tekton trigger again, which will then start the promotion. So the canary promotion process starts immediately. It doesn't happen immediately, but it starts waiting for the correct conditions to promote immediately. And that is this pipeline here. Once the conditions for Prometheus have been met, in other words, our range query says something like, after 5 minutes of there not being any endpoints that have crashed, allow the canary to be promoted. And then 100% of the traffic will go to our canary. And that's just a way of kind of catching any obvious silly problems that you might otherwise push out and cause downtime with. I'm going to have to speed this up a little bit. So this event listener here, the red parts are what I was mentioning earlier. You can use these event listener specs to define the interceptors, so you will match the headers. In this case, we know that the CE type will contain our event type. So with Cloud Events, it's really easy to standardize on using these types to do predictable things. All of the pipeline tasks we will run, I'll try and talk through quickly. First, we're going to use BentoML to retrieve the build context. Next, we use Canico executor to build the context into an image. Canico is a Docker image build utility, but it does not require Docker daemon to build, which makes it ideal in a CI format. Then we're going to use the KFServing canary creator task, and we'll create a canary deployment for our new image. Like we said, it'll get 10% of traffic, and then our Prometheus gate will wait 5 minutes without seeing any pod failure metrics. Once it has, it will allow the canary promoter to run. So what we can do now is we can take a second and check out our canary deployment. Once that's done, we can query our canary, or if it's already been promoted, unlikely, our default endpoint, and we can watch it pass from 10% to 100% traffic. So it looks like here we're looking at our build process still, the Canico process. You can see it's doing a whole lot of pip installing Python modules. It's just building away. And right now what it's doing is pushing up all of the pushing up our Docker image layers up to my Docker repository. But let's get all the pods in our build namespace. You can see here the build tasks themselves happen as pods, and what happens inside them happens as containers as steps. So you can see our BentoML task completed very quickly, but our Canico build is taking much longer, not only because it's running a much more process and intensive workload building an image, but it's also, I think it's doing like 8 different steps. So there's a lot going on, and we can see that it's finished now. So if we were to go back and watch our ML namespace, we can see a lot has happened. We have 2 pods initializing up here. And even though we're set to auto scale down to 0, it'll initially come up and boot these pods right off the bat. And then if they don't get any traffic for a while, they'll go to sleep. But we have, noticed we have 2 pods, a canary and a default. We have 2 sets of services for canary and default. We have 2 routes for canary and default. So we're really just running 2 deployments and having the traffic routed 10% to one, 90% to the other. So what we can do is we can take our route here, which is model-inf-predictor-canary, and then an xip.io here. And we can make a query on our ML endpoint that we just created. So we will set, if we set service equal to this, and we do a simple curl, right. And we want our input path as well to be set to something usable. So we will create that input right now. And then we should be able to make a prediction, and we can see that we get our result here. So we were able to query our canary, and we're able to get a result back. And let's see what's going on in our logs. So here you can see the Prometheus query is underway, and we're just awaiting promotion of the canary at this point. You can see that the value here is 4, so it's going to take a little bit for this namespace to settle. And once it has, it will run through a promotion step, and we will see the canary become promoted. And that is the entire demo. Thank you for your patience as I work through this new format, and I find this a very interesting topic. I'd love to talk more about this with you, so please do engage about it, and have a great day. Yeah, so thank you so much for listening to this session. If there's any questions, I'd love to answer them about anything to do with Cloudevents or Bento or anything else we discussed here at Tekton.
Otherwise, please do stick around. There will be a sponsored video right after this. And I'll wait for a little bit for some questions. But other than that, thank you so much for the opportunity to speak. Right, looks like we have no questions. So again, thank you so much and take care. Cheers.